It looks like we're off to the races with a racing themed problem. Are you all ready for this? Mary and Sally are in a foot race. When Mary is 22 meters from the finish line, she has a speed of 4 meters per second and is 5 meters per second behind Sally, who has a speed of 5 meters per second. Sally thinks she has an easy win, and so, during the remaining portion of the race, decelerates at a constant rate of 0.4 meters per second squared to the finish line. What constant acceleration does Mary now need during the remaining portion of the race if she wishes to cross the finish line side by side with Sally?
So this is kind of a tricky setup. What do they have to cross the finish line at the same of?
The same acceleration.
Not
Oh no.
acceleration.
Same time, same
Same
time.
time. Perfect. They have to cross the finish line at the same time. So, what we're going to be doing here is we're going to be calculating the amount of time it takes Sally to cross the finish line. And then we can use that time and plug it in for Mary to be crossing the finish line in the same amount of time as it took Sally. Now, they have different initial velocities, different accelerations, which we're going to be solving for Mary's acceleration, and they're traveling different distances. So what is our unknown for Sally, and what do we know?
What we know about Sally is she's 17 meters out from the finish line because
Mhm.
she's 5 meters ahead of Mary.
Nice. Do we have her initial velocity?
I believe she has a speed of 5 meters per second.
Nice. What else do we have?
We know that she is decelerating at a constant rate of 0.4 meters per second squared.
Right. So I'm going to put A equals negative 0.4 meters per second squared. Perfect. Now for Mary. What are we actually trying to find with Mary?
With Mary, we have to find her constant acceleration that she'll need to finish alongside Sally.
Yeah, perfect. We have her initial velocity, right? What is it?
Her initial velocity is 4 meters per second.
Perfect. And what distance does she have to cover?
She has to cover the full 22 meters.
Awesome. So this is our setup. We have for Sally, and we're going to start with Sally, we have her initial velocity, we have her acceleration, her distance, and we want to find the amount of time it takes Sally to cross the finish line. With that time, we're going to be able to calculate Mary's acceleration. Let's start with it. What equation from the three kinematic equations should we use to calculate Sally's time?
I think we should use number 2 because the position is included in the problem.
Perfect. We have everything here. The change in position, the initial velocity, time, which is what we're searching for, and acceleration. So I'm going to go ahead and begin filling this in. We have 17 equals, what's the initial?
5.
Perfect. What's the acceleration?
The acceleration is a deceleration of negative 0.4 squared.
Perfect. Meters per second squared. And then we have to square time. This is a little frustrating because this is quadratic. So,
Yes.
quadratic, we have two things. You want to get the equation into the form ax squared plus bx plus c equals 0, and then you want to use the equation negative b plus or minus the square root of b squared minus 4ac over 2a. And this will give you two solutions for your time in this case, because time is the variable. So you replace x with t.
Okay.
Now, and I could just put actually t equals in this case. Normally it's x equals. But let's first start by getting that into the quadratic form, this top equation into quadratic form. Really fast, what is 1/2 times negative 0.4? Just think 4 divided by 2.
Would that be negative 0.2?
Exactly. Plus, or minus in this case, minus 0.2 t squared. Now I'm going to rearrange this so it's just like our first equation. I'm going to add 0.2 t squared to both sides, and I'm going to subtract 5t from both sides. I end up with this, 0.2 t squared minus 5t plus 17 equals 0. Now notice this follows our quadratic form, a x squared plus bx plus c. So what is a going to be equal to?
Would A be 0.2?
Yeah, perfect. What is b going to be equal to?
B would be 5t, or 5.
Negative 5 in this case.
Oh,
It's a little
negative.
tricky. Circle that a little better. And what is c going to be equal to?
17.
Perfect. Let's create our quadratic equation. T equals, what do we put in for the first value here?
T equals negative, would it be 5?
Exactly. Negative of negative 5 just becomes 5 plus or minus the square root of negative 5 squared, which is really just 5 squared because any negative number squared is positive, minus 4 times, what is A?
4 times 0.2,
And then what is C?
17.
Perfect. All over, we have to make sure that if we type this in, we put the entire top in parentheses. I've made that mistake before. This is all over, in parentheses, 2 times A, which is 0.2. Let's go ahead and do that calculation really fast on our calculators. And I'll do this on Google. As you can see, I've already practiced doing this the correct way. I'm just going to start with plus, and we have the square root of 5 squared. I don't have to make it negative because a negative number squared is a positive number, minus 4 times 0.2 times 17. Close parentheses inside that square root, and then close parentheses for the entire numerator. And I'm going to divide this by 2 times 0.2. Now, what we actually get, whenever we do plus here, we get 20.94 seconds. Whenever we do minus, so we get t equals 20.94 seconds. And then when we do minus, we get 4.06 seconds.
Oh, because it's plus or minus, and it's a parabola, and we always rule out one of them as the more sensible answer.
Right. In this case, let's talk about which one of these is the more sensible answer. 20.94 seconds or 4.06 seconds. So here's what's happening.
We were doing the math right. We just had to figure out which of the two was better.
Yeah, exactly.
Okay.
So what happens is Sally is running towards this finish line. And as she's going, here's the finish line. It takes her 4 seconds to cross the finish line. But it's not over there. Because after she crosses the finish line, our problem assumes that she's still running and she's still decelerating. So eventually, she's going to run pretty far in this direction, slow down, and then begin to come back because she's still accelerating backwards, right?
Right.
And so she's going to cross the finish line going the opposite direction after 20 seconds. Does that make sense? Literally, if I'm running and I cross the finish line after 4 seconds, but instead of stopping and being like, I'm done, I keep running, slowing down, and then I start going backwards. And then I cross the finish line backwards after 20 seconds.
Okay.
It's a little weird.
See that. Yeah.
But if it was a parabola, here she is moving, and then boom, 4 seconds, boom, 20 seconds. If 0 is our finish line, then she crossed it initially at 4 seconds, kept running, slowing down, crossed it again at 20. Tricky problem. So the time we're interested in using is 4.06 seconds. So Mary has to cross in 4.06 seconds. Okay, this is some very upsetting news, I know. But now we have to actually solve for what the question is asking for. We have to solve for Mary's acceleration in order to cross the finish line in 4.06 seconds.
But now we have Sally's time that we can plug into Mary's equation.
Exactly. So I'm going to draw a line here, and let's start solving for Mary. Which equation are we going to use to solve for her acceleration?
We're going to use the second one again.
Perfect, because it has delta x, initial velocity, acceleration, which is what we're looking for, and now it has time.
So it would be 22 meters equals 4 meters per second times t plus 1/2 of a times 4.06 squared.
Perfect. I'm going to simplify
we know
this.
t, we could have done 4 times 4.06.
Exactly. And I'm going to do that really fast on my calculator. I get 16.24. And I'm going to do 1/2 times 4.06 squared. So 4.06 squared divided by 2 plus 8.24a. Can we solve for this acceleration now?
I believe so.
What's the first step for the algebra here?
Could we divide each side by 8.24?
That could work. I think the easier method is to start out by subtracting the 16.24 first.
Okay.
But we could divide both sides. It's just we had to divide two numbers instead of just one.
Okay.
So let's do the minus 16.24 on both sides first. So I get 5.76 equals 8.24a. And now we're completely ready for your step.
So we divide both sides by 8.24.
Yeah, exactly. And I end up with 0.70 meters per second squared once I round. Is that what you got?
I did get that. You rounded up after 0.69?
Exactly, because I got 0.699.
Yeah, that's what I got too.
Perfect. Yeah, and that's our acceleration. So Mary has to accelerate at 0.7 meters per second squared to catch Sally, who is decelerating at 0.4 meters per second squared by the time they get to the finish line. Awesome. Any questions about this one?
I see this is another two-step problem where we had to solve Sally to get the information we wanted from Mary.
Yeah, there's a lot going on here. Yeah, to quickly recap, we wrote down all the variables, including the variables that we were looking for. We wrote down our kinematic equations so that we had them on hand to choose from. We solved for the amount of time it took Sally to cross the finish line, and we ended up having to use the quadratic equation. And then we plugged in that time to solve for Mary's required acceleration. Awesome stuff, Matt. All right.